Today's video is on solving rational equations, so solving equations that have fractions where the denominator ends up having a variable in it. So here are some key things, basically taking all of the parts of your directions, solve, state domain, and determine extraneous solutions, and talking about each of them. So solving, we solve like a normal equation. When we have the common denominator, we can multiply through by that entire denominator to eliminate fractions from your equation. This is very similar to what happens if you had an equation like x over 4 plus 3x plus 2 over 3 equals 5. What you would do to probably make your life easier was you would multiply the entire equation by 12. That's because the common denominator of 4 and 3 would be 12. And if I did that, what I would end up doing is getting rid of all of the fractions. So in this problem, I would end up with 3x plus 4 times 3x plus 2 equals 60. That's what happens when I multiply through by 12. And then I could easily solve that equation. Notice it might be easier to think of this as playing the game what's missing, because what was missing from the first denominator was a 3. What was missing from the second denominator was a 4. And what ended up happening was I ended up multiplying the numerator of the first one by 3, and I multiplied the numerator of the second one by 4. And that ends up happening when I take 12 times x over 4 and 12 times 3x plus 2 over 3, what ends up happening is I end up with whatever was missing from the denominator being multiplied by the new numerator. Determining the domain is exactly the same as everything else that we've done so far in this unit. If there's a variable in the denominator and it would make it 0 when you substitute something in, then that must be excluded from the domain. And extraneous solutions are any solution that you get in your equation that is not in the domain. We have to end up excluding that from your answer. So let's do some problems really fast. If I look at x squared minus 7x plus 12, that really factors into x minus 3 times x minus 4. So really, I can just take a look at multiplying through the entire thing by x minus 3 times x minus 4. Once again, that ends up in practice meaning that I multiply each of these numerators by what's missing from that part of the denominator. So 3 ends up getting multiplied by x minus 4. 4 ends up getting multiplied by x minus 3. And 25, I don't have to multiply by anything because I already have the common denominator. So nothing really needs to be multiplied by that in order to get my common denominator. Now, what's really happening is I'm taking x minus 4 and multiplying the top and bottom of the first term by x minus 4. I'm taking x minus 3 and I'm multiplying the top and bottom of the second one by x minus 3. So really, I'm multiplying by fafus in every spot that I have to multiply by. I'm multiplying by 1 in each of these spots. So now what I'm going to do is I'm going to distribute. I have 3x minus 12 plus 4x minus 12 equals 25. If I combine like terms, I have 7x minus 24 equals 25. I have 7x equals 49, so x equals 7. Now that's solving. I didn't actually do any of the other parts of the directions yet, and I probably should state the domain before I do anything else, but I didn't do that, and so now I'm going to go back and fix it. So the domain of this equation, if I look at the denominators, the domain is all x except x cannot equal 3 or 4. Because if I substitute 3 or 4 into this original equation, the denominator would be 0. The good news is 7 is not 3 or 4, so my final answer is good. If I look at problem 2, if I look at the domain, I'm going to do that first. X can be anything except x cannot equal 2. So now let's figure out what I would multiply everything by if I need to. I'm going to multiply this first one by x minus 2 over x minus 2, and the other two terms don't need to be multiplied by anything in order to get a common denominator. So I have x times x minus 2 plus x equals 2. And really quick, just to make sure we're all on the same page, all of these things would have an x minus 2 denominator, but I don't need to keep the denominator because if I multiply through by the entire denominator, it goes away, just like when I multiplied through in this first equation that we talked about by 12, all of the denominators end up going away. So I'm going to get rid of the denominator in order to make my life easier in solving the equation. So I have x squared minus 2x plus x equals 2. I will combine like terms and subtract 2 over to the other side. And then I will factor, so I get x minus 2 times x plus 1 equals 0. So I end up with the answer of x equals 2 and x equals negative 1. But before we move on, we have to recognize that my domain said that x could not equal 2. So since x equals 2 was one of my answers, this is what we call an extraneous, and I'm not going to write the whole thing because I'm going to run out of room, extraneous solution. So that means x equals 2 is not one of my answers. So my final answer is only x equals negative 1. Problem 3, if I look at x squared minus 3x plus 2, the common denominator is x minus 1 times x minus 2 when I factor that. So I'm just going to multiply everything by what was missing from that denominator. So 4x gets multiplied by x minus 2, negative 5x gets multiplied by x minus 1, and 2 does not need anything multiplied by it. So now I'm going to use the distributive property 4x squared minus 8x minus 5x squared plus 5x equals 2. I will combine like terms. Negative x squared minus 3x minus 2 equals 0, and I moved the 2 over to the other side. I will multiply through by negative 1 or add everything over to the other side, however you want to think about it, in order to make the factoring easier. So I end up with x plus 2 times x plus 1 equals 0, which means x equals negative 2 and x equals negative 1. Once again, I forgot to state the domain. It's not a really good habit to continually forget to state the domain, so your teacher is modeling poor behavior here. So the domain is all x's except x cannot equal 1 or 2. Well, the good news is x equals negative 2 and x equals negative 1. Neither of those is excluded from the domain, so both of those are acceptable answers. If I look at problem 4, the domain is going to be all x except x cannot equal negative 5 or negative 7 halves, because that would make the denominator equal to 0 if I substituted either of those in. So now what I'm going to do is I'm going to multiply each of these parts by what's missing. Notice that 3 is missing both parts. So 3 is going to get multiplied by x times, or x plus 5 and 2x plus 7, minus 22 times 2x plus 7. That's the part that's missing from here. And then the part that's missing from the term on the right side of the equal sign is x plus 5. So I have 6x minus 1 times x plus 5. So now what I'm going to do is I'm going to end up solving this. So 3, excuse me, 3 times 2x squared plus 17x plus 35 minus 44x minus 140 and 14 makes 154. And this ends up being 6x squared plus 29x minus 5. Now I want to combine like terms if I can. Well, first I'll distribute this 3. So 6x squared plus 51x plus 105 minus 44x minus 154 equals 6x squared plus 29x minus 5. Notice that the 6x squareds end up canceling out since there are some of them on each side of the equal sign. That's quite nice. So 51 minus 44 is 7, and I'll subtract that over to the other side. I get 22x. And then 105 minus 154 is negative 49. I will add 5 over, and I will get negative 44. X equals negative 2 when I do all of the math, and that is not excluded from the domain. So that's good. X equals negative 2. One thing that we're going to notice about problem 5 is we have 2 minus x. 2 minus x is the same thing as the opposite of x minus 2. So that's very important to note. So if I try to substitute values in, my domain restrictions are going to be all x's are cool, except x cannot equal -2 or +2. And notice that x squared minus 4 will uh, end up having +2 and -2 as our things anyway. So what I'm going to do is I'm going to rewrite this as 2 over x plus 2 plus x over x minus 2 equals x squared plus 4 over x squared minus 4, which if you factor x squared minus 4, it's x plus 2, x minus 2. So notice what happened was I had the opposite of x minus 2. So I changed 2 minus x to negative x minus 2. And then what ended up happening is I had minus a negative, which ends up changing it to plus a positive. So now I'm going to figure out what's missing. What's missing from the first term is an x minus 2, or what's missing from the denominator is an x minus 2. So I'll multiply that by the numerator. Plus x times x plus 2 equals x squared minus 4, or x squared plus 4, sorry. So now I have 2x minus 4 plus x squared plus 2x equals x squared plus 4. And now I'm going to simplify things. So the x squareds end up going away. I end up with 4x equals 8 and x equals 2. Notice that x equals 2 is in our domain restrictions. So that means x equals 2 doesn't work. And this problem has no solution. No solution for problem 5. We got one answer, and that answer was extraneous. So because that answer was extraneous, I have no solution in problem number 5. Problem 6, if I factor x squared minus 3x minus 18, that's x minus 6 times x plus 3. So what I'm going to do is multiply everything by what's missing. So I have 5 times x plus 3 minus x plus 39. I'm going to put that in parentheses because this negative will get distributed to both parts, equals 4 times x minus 6. Before I go too far, I should probably write down what my domain is. All x except x cannot equal -3 or +6. So now let's distribute. 5x plus 15 minus x minus 39 equals 4x minus 24. Let's solve everything. I get 4x minus 24 equals 4x minus 24. If I got rid of everything, I would get 0 equals 0. That would mean I have all real numbers as my solution. So every number works, except remember, I had some domain restrictions. So the answer for x would be all x, except x cannot equal -3 or 6. So I end up with any answer except for the things that didn't work in the original problem. So my extraneous solutions cause me to not have all real numbers. It causes me to have all real numbers except -3 and 6. Number 7, x plus 2 times x minus 6. So x minus 6 is missing from the first one. Plus x minus 2 times x minus 3, that's what's missing from the second one, is equal to 2 times both things are missing. That's x squared minus 9x plus 18. So I just ended up multiplying that out to make this a little quicker. So I have x squared minus 4x minus 12 plus x squared minus 5x plus 6 equals 2x squared minus 18x plus 36. Notice there's 2x squared on both sides, so that ends up going away. I have negative 9x minus 6 equals negative 18x plus 36. When I start solving, I get 9x equals 42. So x equals 42 ninths, which can be reduced to 14 thirds. So x equals 14 thirds, I should probably check my domain. All x, except x cannot equal 3 or 6. Since x equals 14 thirds is not 3 or 6, that's good. So x equals 14 thirds is my final answer. Finally, If I factor the denominator of the right side of the equation, that's x plus 2 times x minus 5. So my domain is all x, except x cannot equal negative 2 or 5. I'm going to multiply by what's missing, so x times x minus 5 plus 7 times x plus 2 equals 14. Note, I don't have to multiply anything by the 14 because nothing was missing from that denominator. So I have x squared minus 5x plus 7x plus 14 equals 14. I get x squared plus 2x. If I subtract the 14 over, that equals 0. So now I can factor out the greatest common factor. So I have x equals 0 and x equals negative 2 as my answers. Notice that x equals negative 2 was part of the domain restriction. So x equals negative 2 is not a possible answer, and x equals 0 is my only answer. So negative 2 was an extraneous solution, and x equals 0 is the only answer in that problem.